So hey guys, welcome back to my channel. Hope you're doing extremely well, and this is your very own mask code on this side. So in today's question, we are asked to move all zeros to end. What does the question say? The question says that you have been provided an array. You can see there is an array given to you, right? And you can see that some of the elements of the array are zero, right? Some of the elements array are zero, right? Array does, or I can say can contain zero, right? Array can contain zero. The problem is asking you to shift all zeros to right end, That is, as you can see, there are three zeros, 1, 2, 3. That is, your right part of the array should look like 0, 0, 0. Now your question should be, what should your left part should look like, right? So all the elements which are non-zero. So this is a non-zero element, 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 and this is a non-zero element. So the question says that put that in the left part. Also, how to put them? Without reordering. Without reordering. What does that mean? It means that 1, 2, 4, 3, 5. 1, 2, 4, 3, 5 will have to come as it is. You cannot change the order between these elements. It cannot be 1, 4, 2, 3, 5. It had to be 1, 2, 4, 3, 5. Right? Now, if this condition was not given, the problem is actually very easy. You just reverse sort it. If this problem is not given without reordering, right? But it is given, so we have to think of something else. So how to solve it? If I see the brute force method, what can I do? I will say that I will pick out the non-zeros element in one vector, non-zero elements in one vector, and zeros, number of zeros in another. Like you can take a counter. So I can take count equals to 3, which is equals to number of zeros. Right? Now what will I do? I will form the new array. I will put all the elements 1, 2, 4, 3, 5, and then I will put the number of zeros here, right? So what does that do? It is running in O of n time complexity and O of n space required because I'm using extra for all the non-zero elements, right? Now, can I do it in place? Can I do it in place? What does that in place means? In place means that I do not have to use any extra space. That is, I have to do it in O of 1. I have to do it in O of 1 space complexity. Time complexity is nothing mentioned in the question, right? So how can I do it in place? So my simple technique is, let me write down the array again below. What I am saying is I need all the zeros at the end, right? So 1, 2, 0, 4, 3, 0, 5, 0, right? What can I do is I can start from here. I can keep a I pointer here. I can keep a PTR here. What will I do? I will see that ARRI is not equals to 0. If ARRI is not equals to 0, what do you do in this case? You just replace your array I with PTR. So in that case, the PTR elements is changed to ARRI and then PTR plus plus, right? That is 1 will remain 1. After that I comes here, PTR comes here. Again same condition, so this 2 changes to 2 only, right? This I comes here, but now this element is, the PTR is also here, but now this element is 0. For the case of 0, you just increment. You do not do these two steps, right? I comes here. Again, now 4 comes here. That is, this 4 changes. And PTR comes here. I goes here. Again, this changes to 3. I comes here. PTR comes here. This again 0. So I will surpass, right? 5. That is, this 3 will change to 5. And I will come here, right? PTR will also come here. I changes to 0, so I will surpass, right? So as you can see, my array has changed to 1, 2, 4, 3, 5. That is, left half of the array is done. I needed this only, right? I need 3 zeros now. So as you can see that if the difference between the position of I and PTR at the end, the difference between position of I and PTR in the end is to be filled with zeros, right? Is to be filled with 0 because that are the only points when I surpass PTR with 0. So what will you do? You will say that the number of position left for PTR to cover them all with zero. That this will change to zero, this will change to zero, this will change to zero. And final answer will look like 1, 2, 4, 3, 5, 0, 0, 0. Exactly what you needed, right? Now you can see we just use two pointers and a traversal. So because of traversal, time complexity becomes O of n, and because it is constant space, so O of 1. So this is an in place as required question, right? It is very easy to understand, and I hope no more to, like, I don't want to spend more time on it because it is actually very easy. We will spend a good amount of time on a medium or hard question, right? So let us go to the coding section of it. So as you can see, here is the coding section. What will I do? I will create a PTR equal to 0 and I equal to 0 as discussed. Now, while I is inbound to the array, condition is if arri is not equal to 0. In that case, change your PTR element to arri. After changing, you have to increment it. So I'm using post increment here. Otherwise, in both the cases, I have to go to the next element only, right? After the traversal is complete, all the elements, including PTR and rightwards, are to be changed to 0 because that are the number of zeros in the array. ARR PTR plus plus equals to 0 and return. As simple as that. Only two loops and moreover only one traversal, right? Okay, so let us try to submit it for the hidden test cases. Running the counter going up, and thank you. I hope you liked it, and make sure to like and subscribe to the video, and subscribe to the channel for the new updates, right? So I hope you are excited for all of that. Thank you. Have a nice day.